Hello, my name is Ada Chaudhary and I have made a project using artificial intelligence to make art. Let's get into it. But before we start, let's go over some of the basic AI terms that I have used in this project. So first is machine learning. Machine learning, or known as ML, is a type of artificial intelligence that allows software applications to become more accurate at predicting outcomes without being explicitly programmed to do so. This means that machine learning softwares are good at finding patterns from data without being told what patterns to find. So as they work, they using their algorithms, they find patterns from the data that we provide. It is basically of four types, that is supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. Let's focus on unsupervised learning as I have used a neural network that utilizes that. So unsupervised machine learning algorithms do not require data to be labeled. That means that you do not need to classify data on the basis of its similarities or differences. The algorithm sifts through the unlabeled data to look for patterns that can be used to group data points into subsets. So it classifies the data on its own. Most types of deep learning, including neural networks, are supervised algorithms. In this project, we would be using a typical type of neural network, so pay attention. Unsupervised learning algorithms are good for the following tasks: clustering, that is, splitting the data set into groups based on similarity; anomaly detection, that is, identifying data points that are unusual; and association mining, that is, identifying sets of items in a data set that frequently occur together. And the final is the dimensionality reduction, that is, reducing the number of variables in a data set. So the first three are remotely associated with finding patterns and classifying them, and the last one is to make the whole process a little bit smooth. Now, what are neural networks? So, as the name suggests, neural networks resemble the human brain, which is made up of neurons. So, it mimics the way that biological neurons signal to one another. So, these networks rely on training data to learn and improve their accuracy over time. Much like the brain takes in data over time and strengthens its neural connections to become more accurate in its day-to-day working. So, in a neural network, there are multiple layers, and each layer, after its processing, gives the output which allows the next layer to function. So, it is a step-by-step process. With this, we complete basic terminology. Now we can get into the neural network that I have used in the program. That is known as generative adversarial networks. So as the name suggests, it consists of adversarial networks. That means there are two networks in opposition with each other. So in GANs, there is a generator and a discriminator. The generator generates fake samples of data, be it an image, audio, etc., and tries to fool the discriminator. And the discriminator, on the other hand, tries to distinguish between the real and fake samples. So, both of these are neural networks and they both run in competition with each other in the training phase, hence the name adversarial network. You can think of generator as a thief who is trying to fool the police, that is, the discriminator, by creating counterfeits. So, its main purpose is to create counterfeits that come as close as to the real data that we have provided it. So as this program runs, the generator starts to generate fake samples of data from fake samples from the data you provide, and it sends to the discriminator. Now, initially, its accuracy is low. So, uh, over the iteration, it improves its accuracy, and finally comes a point when the discriminator actually labels one of its fake counterfeits as real. So as the discriminator gets fooled, now it improves its accuracy by modifying itself. So as the number of iterations go forward, both of the generator and the discriminator, on the basis of their success and accuracy, improve themselves, and hence the general result of our data improves. This image basically explains how GANs work. So we input random noise or unlabeled data, and in the generator it tries to create a fake image, and it sends it along with the training set that was initially provided to the generator to train itself. So now it's the discriminator's job to label it as real or fake, and the accuracy with which both of these networks work with uh, is improved over time as the number of iterations increase. Now, it in to implement this network, there are a lot of hardware requirements, and frankly, I did not have access to any of them, not even the most basic ones, that was Windows 10. I have a tablet, I have a Samsung tablet, so I do not have access to a laptop or any hardware and or GPU drivers or any CPU. So I had to find a way where I could practice uh, working with artificial intelligence models with the hardware I had. So basically, that was a phone, an Android phone, and a tablet, an Android tablet. So the solution that I found was Google Colab. Now, Google Collaboratory is a free Jupyter notebook that runs on Google's cloud servers, and we can use hardware like GPU and TPU to practice our deep learning models, and we do not even require the installations and setup for hosting our notebook in a local machine. So that solved my problem for not having enough storage or processing. With this, we complete our presentation, and now here I have my Google Notebook opened, where I have coded the programs for GAN, for implementing a GAN. So for in Google Notebook, you can implement your code in snippets. So this first snippet, we mount our Google Drive, because at some point you are the server can log you out and you may lose all your progress. So I have connected my Google Notebook with my Google Drive. So all of my updates get automatically saved, and also the first step is to go to runtime and change runtime type, and here I have selected my hardware accelerator as GPU. So that is your graphic processing unit, which you will use to generate your own images or artwork. With this, the first function that we encounter in this program is generate the images. This program is coding our generator network by specifying how many layers of we will use in our neural network, and what is the size of it, and what kind of kernel size and strides they have. This is our output that we get, uh, which shows our layers and the output that they give. The second is to generate our training data, in which we create a fake model generator in which we just input random noise to the generator to see how it functions. Now here is its output. As we have put random noise, so it gives us blank images, which is expected. The second is the program to make the discriminator. Here also we have specified the number of layers we have in this neural network, what kind of kernel size, the padding, the input shape, and its activation layer. This is our output for that, in which we are firstly specifying our requirements, that is basically installing all the packages. Sometimes in the Google notebook you have to install your own packages in case they are not already provided. And this is the layer and the output that it gives. In this snippet, we are importing our data set. In this program, first to train my data, I have imported a very popular image data set known as Cipher 10. Now it consists of 60,000 images divided into 10 classes. So the reason I've used it is that it was easy to access and to train. Uh, then we normalize the data to make it easy to process. The second is the generate real and generate fake functions. Now this snippet is used to train our discriminator network. To do so, we will need both real and fake images. So we create a function that generates that. So in order to generate fake images, we have to make sure that they have the same dimensions as the real shape. And in this program, I have specified them as 32 as real images as arrays of 32 by 32 by 3, and we create n images with this shape. And we give the label 0 to fake. Now taking the fake and the real images that we have generated, we pass them to the discriminator function, in which we train the discriminator beforehand, because when we will train the GAN, we will be only training the generator. With this function we get this output, which it specifies the number of real and the fake images. The final function is the create GAN, in which we bring together all the functions that we've created, and we use the model discriminator and the model generator, which we programmed earlier. Now this snippet saves the results of our model. So we have had an array of generated image, and we store 10 such arrays. Also, the second function that you can see, the def evaluate function, evaluates the performance of our classifying network. So with this function we see how accurately our GAN is at classifying the unlabeled data to find patterns within it. Now we have all the functions we are going to need. Now we can train our GAN with the function training. In this, we iterate over the epochs, that is the number of iterations. So the number of iterations, the more number of iterations you give, the better your results will be. And that also depends on how much RAM you're using on the Google Notebook. So in case you are having a lot of epochs, that are a lot of iterations, then I would recommend you to load your data on the Google Drive periodically, because when the when the RAM requirement gets fulfilled, the program often crashes. So if that happens, you can load your data, your progress once again after it crashes, so you won't lose anything. So in this, we iterate over all our batches, we load all the real data, we train the discriminator, we generate the input images, we train the GAN with the fake data, and every 10 epochs, we show the results and the cost. Now this is the output that we get. I have, because in this one I have used epochs 10 to test whether my program is functioning correctly or not. Let's see. So this is our output that we get with 10 epochs only. And in this final one, we visualize the images that the GAN has created by displaying the arrays in which we stored. And this is the set of images that I get. Now these may look blurred to you, because we have specified the number of epochs as 10, so that's quite low. Now one thing we can do is increase our number of iterations, and then we can get better results, and by loading our data into the Google Drive. We can so this is how you train a GAN. Now this program is very versatile. Depending on whatever data set you give, you can get any type of images. Now if you prepare a data set containing artwork or pictures of paintings, then you will get a generated painting of your own. Here I have included a few programs to give a tutorial on how to create your own data sets. So this program creates a NumPy array from a folder in Drive. Now I can use NumPy Shuffle to divide the data into testing, training, and validation, which is used to train the discriminator and the generator. Now it also shows the first image in the saved array. Let's see the output. Here it is. So in this I have put the dimensions as 100 into 100 into 3, and this is also the image of my first day in school for my senior year. Now the second method that I have included is how can you turn a folder in Drive to create a data set similar to the Cypher10 which we have used in this program. So Cypher10 consists lots of classes. So for this folder, you will need a folder that consists of many folders inside it. Now I have been curating my childhood images, my personal images that I can find from up till the 16 years of my life. So this it takes a lot of time to curate all these images. So once I do make that folder consisting of all the years of my images, I will input it in this to make a directory. Now this directory will I, with this when I get that data set, I can just input it in the place of cipher10 as I have done in this program. So this data set making program consists of 5 snippets. Each of them like normalize the data into RGB format and make the data ready to go into the GAN algorithm. So with this, I complete my project, and this is still a work in progress. I believe that with this main structure, you can create anything you want to. Just by changing a few of your specifications, you can create your own data set, and you can increase or decrease the number of iterations to get finer images. And I had a lot of fun making this program, and I hope that anyone else who is watching it also could take away something. And yeah, thank you for this wonderful opportunity.